Hello, pre-calculus students. I'm working on getting you through all the trig identities of chapter 5, but actually proving them to you and showing you quick ways of rederiving them when you need them in the middle of some calculus exam next year. All right, so we just did the cofunction identity. That was the previous video. And the reason we did it was because we need it right now to get the addition subtraction identities for the sine. So you remember we already had the cosine addition subtraction identities. Okay, so that cofunction identity that we want to use here, I notice I've flipped it. Instead of saying the cosine of the complement of the angle is the sine, I've just reverse the equation, right? Which A equals B, then B equals A, right? The sine of an angle can be described as the cosine of its complement. And remember how that came down to what the name cosine really means, right? So therefore the sine of, now let's stick in for the angle theta, let's stick in the whole sum of two angles A and B. That's going to be equal to the cosine of the complement of, instead of theta, we have A plus B. Well, let's do a little algebra. Let's distribute the negative through there. We're taking the cosine of pi over 2 minus A minus B. And now let's regroup those carefully into being the cosine of pi over 2 minus A. So the bit that you really kind of have to memorize is how to carefully regroup. All right, so once you have the cosine of something minus something, oh, well, we have an identity for that. The cosine of alpha minus beta is cosine alpha, cosine beta, plus sine alpha, sine beta, right? That you should have that going immediately now. If we let alpha equal to pi over 2 minus A and beta just B, then we can say the sine of A plus B, right? Which we had down to here. Using the cosine of the difference of angles identity, we get that the sine of A plus B, I might need to adjust the screen now because now I'm getting down here where you have some glare, trying to put less glare on your screen. Let's try that for a while. Okay, the cosine, using cosine of alpha minus beta, we're going to get the sine of A plus B is the cosine of pi over 2 minus A times the cosine of E, plus the sine of pi over 2 minus A. You see how I'm just substituting that in for alpha in that expression. Sine of pi over 2 minus A times the sine of B. Okay, well, bring out your cofunction identities again. What is the cosine of the cosine, with cosine of a complement of an angle? That's just the sine of the angle. Definition of what a cosine really means. And the sine of the complement of an angle, by our cofunction identity, that's the same thing as the cosine of an angle. That's the definition of the cosine of an angle. So this results in us having this as our addition identity for the sine. The sine of the sum of two angles. Okay, and this is the one you kind of have to memorize. So here's some devices to help you with that. Notice that the sine of a sum of two angles, it's almost like you're distributing the sine through there. You start with the sine of A, but then remember, and this is what you want to remember, you got to mix it up from here on out. If you had the sine of A, the next one should be the cos of B. Keep mixing it up for the sine. The next is the cosine of A, sine of B. Make sure you have a sine and cosine of each angle, and that you always change up from sine to cosine to sine, no two adjacent. It's not like the sine, the cosine of A plus B, right? Cosine of A plus B is sitting right here. If I replace, oops, with a different color, I replace that with a plus. Remember how we memorize these together? If you put a plus here, the cosine of alpha plus beta looked exactly the same, but there was a minus here, okay? So compare that with the sine of A plus B. It's not cos, it's sine of A, cos of B. Cos of A, sine of B. Mix it up. One benefit here, though, is that we have, for a marker of the different color, is that we have, you can see, if you see the sine of A plus B, you're going to have a plus there as well. That's different from the cosine, right? All right, so whatever devices you need to be able to memorize that, you'll need it. Well, actually, let me show you that if you take this further, you get some help. Okay, now I definitely need to change the angle here so you guys can see without reflections what's going on there. Pardon me. Okay, so, so we have the sine of a plus b. To get the sine of a minus b, remember the trick from before. Substitute in for b the opposite of b and use the symmetries. So the sine of a minus b, once you have this one memorized, you just plug in a minus b for every b. The cosine of the opposite of an angle is just the cosine of that angle. The sine of the opposite of an angle is just the opposite of the sine of that angle, because cosines are even and sines are odd. And that gives you, I think I just put it right back into glare mode, sorry. One jiggle and it's all over. There we go. That looks better. So the sine of a minus b is sine of a cos b minus cos a sine b. Again, you're not going to memorize all that so much as memorize kind of one of them, and the fact that if you change this from a plus b to a minus b, you change that minus, that changes to a minus. The idea that that's what's going on, that's what you want to memorize. Let me back up a little bit more so you can see that's the last line. Okay, so now here's the one you're going to be using a lot in Calc 2. Okay. Same trick again that we did with the cosines. If we have a sine of sum of two angles, we can replace both of them with theta. So the sine of theta plus theta, or also known as the sum of twice theta, double an angle, is equal to, substituting in all those a's and b's for thetas, the sine of theta times the cosine of theta, plus the cosine of theta times the sine of theta. Wait a minute. Multiplication is still commutative. So that's really two of these cosine theta sine thetas. What? So the sine of twice theta is equal to 2 times the cosine theta sine theta. That is going to save you so much grief when you're looking at some kind of, you're trying to integrate a product of a sine and cosine. Just get that constant 2 in front of it, and you can squinch the cosine sine product, instead of taking an integral of that, to just taking the integral of the sine of twice the angle. This double angle identity for the sine gets used a lot. So the main 3 identities here were the sine of the sum of 2 angles. How do we get it? By using the cosine of the difference of 2 angles with a cofunction identity. The sine of the difference of 2 angles is just a slight modification of that. From it, we get the sine of twice of an angle. Now, how do you memorize that? One of the ways to memorize that is to realize you can get the plus or minuses here, right? By what makes this lovely formula, which students don't seem to have a hard time memorizing. What makes this one happen, right? You wouldn't get the sine of twice theta is equal to 2 cos theta sine theta if you had, instead of a plus here, a minus, right? So that tweaking this, your memory of this, this nice fact can be true. That seems to help. All right.